Two. Everyone should have their hand up. If your hand is up, we did these last year.
We did. I taught you about it.
Okay. The only thing different was slant and parabolic asymptotes. This is the only new piece right here. Everything else is the same. Okay, so, Ashley.
It's already on.
It's on?
Yeah.
Oh, okay. First thing we're going to do is let's look at, with it being unfactored, can you tell me what the degree of the numerator and the denominator are? 1 and 2. So this is bottom heavy. If it's bottom heavy, we have y equals 0 is your horizontal asymptote. Remember, there's 3 cases. If it's top heavy, bottom heavy, or if the degrees are the same. So you'll have one of these. Next, you are going to want to factor your numerator and denominator completely. Well, the numerator is already factored. The bottom factors to be 2x plus 1 and x minus 3. Your vertical asymptotes are where the denominator is set equal to 0. So x is equal to negative 1/2 and x is equal to 3. These are where you're going to have broken vertical lines where the graph cannot cross. So where is x equals negative 1/2? Right here. And x is equal to 3. Okay, and then we also have y equals 0. Y equals 0 is a weak asymptote. The graph can cross or in the middle, but it's not going to cross. It's more for the ends. Your roots are where the numerator is equal to 0. So we have a 0 at 0, 0. Your y-intercept. How do you find any y-intercept? You plug 0 in for x and you're going to solve 0, 0. There are no holes because we didn't cross, there was nothing removable. Nothing was crossed out. So you're going to plug your critical values. Your critical values are 0, negative 1/2, and 3. A critical number is where the numerator or the denominator is set equal to 0. So 0, negative 1/2, and 3. Now when I plug in my exclusion chart, I'm going to do negative 1/2 here because negative 1/2 is the smallest of the 3. Then 0, then 3. And I'm going to put in my exclusion chart all 3 of these. So x, 2x plus 1, x minus 3, and then f of x. So now, what you do here is you find your 0. It's one of these 3 is going to be your 0. Where is x equal to 0? Right here. So to the left, these are negative, and to the right, these are positive. If I set 2x plus 1 equal to 0, which one of these generates a 0? Right here. So to the left are negative, to the right are positive. And at x minus 3, reads my 0 right here. So these are negative, and this is positive. So now this f of x is an important row. You are going to count up how many negatives you have. An odd number of negatives results in a negative. An even number like this is positive. 1 is negative, positive. So this row right here is figured out by the number of number of negatives in each column. If there's an odd number of negatives, it's negative. If there's even, it's positive. This row right here tells you if your graph is negative means below the x-axis, positive means above the x-axis. So from negative infinity to negative 1/2, which is right in this region. So you're from here to here, it's saying we are in the negative region. So we want to be placed somewhere in this area. So we're going to go like this. We're just going to sketch a graph like that. From negative 1/2 to 0, it says we are in the positive region. So the asymptote guides you along. Now we can cross a horizontal asymptote, and we have to. Between 0 and 3, it says that we are in the negative region. So we're going to kind of go like this. And then from 3 to infinity, we're in the positive region. Now if we type this in our calculator, we're going to type in new document, no, add a graph. Now when you type it in your calculator, type the original problem. So we're going to type in x on top, and then 2x squared minus 5x, and then minus 3. And then let's hit graph or enter and check it out. How close are we? Pretty darn close. There it is. Now what the calculator will not show you, it's not going to show you your vertical and your horizontal asymptotes. It's not going to show you your hole either, any kind of a hole. You have to hit Control T to look for any undefined values. So any asymptote will show up as an undefined. See how this says 3 undefined? Now check out the negative 1/2. It doesn't show it to you because there's no fractions for my x value. You have to change your chart. Next one, number 2. So out of these 7 things, what can you do? Which one of these can you do right away? It's unfactored. It's top heavy. And it's top heavy by what? 1. So that means there's a slant asymptote. There's not a horizontal and there's not a parabolic. How do you find your slant asymptote? Well, I can do synthetic division for this one. If I put a 1 here, why a 1? Because the opposite of x minus 1, if you set this equal to 0, it's 1. And you're going to put 1, negative 1, and negative 2. Bring down your 1, multiply, add, multiply, and add. Now you don't need the remainder. You just need these bottom numbers. So y equals 1x plus 0. That's your slant asymptote. How do you graph y equals 1x? Just like that. That's your slant. Now let's factor the numerator. If we factor the numerator, we get x minus 2, x plus 1 over x minus 1. Nothing cancels here, so there is no hole. There is none. How do you find the roots? The roots are where the numerator is set equal to 0. So 2, 0, and negative 1, 0. So where's 2, 0, and where's negative 1, 0? These are big hints. Your vertical asymptote, you set the denominator equal to 0. X equals 1. Let's draw that. Your y-intercept, you're going to set 0 for x. If I put a 0 here, a 0 here, and a 0 here, you get 0, 2. So this thing's hitting the y-axis at 0, 2. Now, the rest of it is going to be found by doing this exclusion chart. You're going to put these 3 factors here, x minus 2, x plus 1, x minus 1, and then f of x. F of x is your total. And now what are your critical values? 2, negative 1, and positive 1 are your critical values. Critical values are where you get a 0 any place in the problem. It's kind of like when you're watching a scary movie and all of a sudden the music changes, dun 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 dun. What kind of feeling do you get when the music changes?
Tense.
Something's going to happen. It's something's going to happen. Something's going to happen when you get to 2. Something's going to happen at negative 1 and 1. So let's look at the changes. So I'm going to put negative 1 here, 1 and 2. You know why I put it like that? Because if I were to think, I want to think of a number line. And I want these numbers, if I were playing around with a number line, there's -1, here's 1, and here's 2. Like that. So the first thing you're going to do is locate your 0 here. Which one of these is your 0? Right here. So to the left, these will all be negatives, and that'll be positive. X plus 1, there's your 0. That'll be negative, these will be positive. So in other words, if I picked a number in this region, is it going to be negative or positive? Well, here's my 0 at 1, so to the left will be negative, and to the right will be positive. Now we count. How many negatives do you have here? 3. 3 is odd, so it's negative. 2 is even, positive, positive, and negative, positive. Wait, this is going to be positive. Oops, this is supposed to be positive right here, so this should be negative. No, it's right. So negative, negative, positive, positive. So we count, we have 1 negative, so that's negative. So from negative infinity to -1, we are in the negative region. From negative infinity to -1, we're in the negative region. So that means we're in this region, like that. From -1 to 1, where are we at? We're in the positive region. So from here to here, we're going to pick up this y-intercept and shoot up towards that asymptote. From 1 to 2, it says we are in the negative region. And then from 2 to infinity, we're in the positive. Here's your graph. You can type it in your calculator or a check. Let's type it in. So we're going to do a fraction. We have x squared minus x minus 2 over x minus 1. And let's graph this. Let's see how close we are. How does that look? Pretty good. So what don't you see here are your asymptotes. That's what a calculator is not going to show you. Okay, the third one. So let's look at the degree of the numerator and the denominator. It's top heavy by how many? 2, so that means there's a parabolic asymptote. That means there's no horizontal, there's no slant. To find the parabolic asymptote, what you have to do is either synthetic or long division. We can't do synthetic division here just because. We can't. It's x squared. It's not degree of 1 and leading coefficient of 1. So what you're going to have to do is long division. You're going to have to divide this into that. Whoops, this is a 4. What you get 4? So we did long division in section 4.1. What you're looking for is the polynomial that results when you divide this into this. It's going to be x squared. I don't care about the remainder. So your parabolic asymptote is y equals x squared. What does y equals x squared look like? It's this parabola. And I really shouldn't put dots because it's not part of the graph. It's a broken parabola, meaning the graph is going to get closer and closer to it but not cross it. So we have a parabolic asymptote so far. The rest of this stuff, we have to factor x to the 4th minus 1. You should know this is the difference of two perfect squares. X squared minus 1, x squared plus 1, and then this factors to be x minus 1, x plus 1. So our roots are where the numerator gives us a 0, so 1 and -1. This is imaginary, so it's not it's not going to hit the x-axis anywhere. Your vertical asymptote is where the denominator is equal to 0, so x is equal to 0. So we have this asymptote. We have two zeros at -1 and 1. Our y-intercept, well, if we put a 0 here and a 0 there, you can't have any y-intercept because it's an asymptote. There is no hole because I'm not crossing anything out. So we're good. Now how do we do this exclusion chart? You're going to put x minus 1, x plus 1. You could do x squared plus 1, and you can do x squared together, actually. And then your y value. So I only have 3 critical numbers, 1, -1, and 0. This is nothing. So let's put -1 here, 0, and 1. So let's find our first critical number. If I were to set this equal to 0, here's my 0 right here. So these are negative, this is positive. This one, my 0's right here, so that's negative, these are positive. Now what's cool about these ones, no matter what number I put in and square it, if you put a positive or a negative number and square it, what does it come out to be? Positive. So if I take a positive number and add 1 to it, guess what? Straight across, they're all positive, because there is no 0. Same with this one. If I were to set this equal to n, it's all positive. If you were to square, it's all positive. So now count. How many negatives do you have here? 2, so it's positive. 1, negative, 1, negative, positive. So from negative infinity to -1, we are in the positive region. So I'm going to follow this asymptote. Then it says from -1 to 0, where are we at? In the negative. And then from 0 to 1, we're in the negative. And from 1 to infinity, we're in the positive. Questions? Okay. Now, this is the one we didn't do on Friday. So let's continue on. 2 unfortunate things in this problem. The one unfortunate thing is we have a parabolic asymptote. Why do we have a parabolic asymptote? You tell me. Because it's top heavy by 2. So there is none of these 2. It's a parabolic asymptote. But the nice thing about this parabolic, there is a ray of sunshine here. What can we do to find this parabolic asymptote? I'm going to squeeze it in right here. What can we do? What am I setting myself up for? Synthetic division. Why am I doing synthetic division? Because we can on this one. Whenever you can do synthetic division, do that. We don't need this remainder, it's worthless. So y equals 1x squared minus x and then plus 1. Now, I am not teaching you how to graph a parabola at this point. This is something you should know. So what I have here on this lovely calculator, my old school calculator, I have typed in here what? X squared minus x plus 1. If I graph this, this is the parabola. You should know how to graph a parabola. But let's say I'm just going to use the table, some table of values. So I'm going to use these numbers right here. I have 0, 1, and 1, 1. And then I have negative 1, 3. And I have 2, 3. My guess is my vertex is going to be somewhere, oops, you guys didn't see that. So that's a general sketch of this parabola. Now how am I going to sketch it? I'm going to sketch it with a broken line. Because this is not part of the graph. It's not part of it. So everyone, this is review, you should be able to sketch that. Use a calculator if you have to. The next. All of these need to be done. But what's the other problem with this one? How do you factor this? Remember what it is? We just took a test on this. X plus 2. X squared minus 2x plus 4. So we have x plus 2. So everyone should be able to factor x cubed plus 8. It's the sum of two perfect cubes. Now, this is a good 0 at -2. So that's a root, -2, 0. That's good. Our vertical asymptote is x equals -1. That's good. We can do that, like x equals -1. Now, does anyone know, do I have anything important right here? No, you don't, because this is imaginary. If you were to graph this, and I'm going to graph it for you on my calculator. If I graphed x squared minus 2x plus 4, and I want to see where it hits the x-axis, guess what? It doesn't. It doesn't. This little piece right here does not generate any roots of any kind. So the only two critical values that we have are at -2 and -1. Okay? Our y-intercept, if I plug a 0 in here and here, where is it crossing the y-axis? If I replaced 0, what's 0 cubed? 0. What's 0 plus 8? 8. What's 0 plus 1? 1. What's 8 over 1? 8. So my graph is going to contain 0, 8. Where's 0, 8? Let's pretend like 0, 8's right here. Let's just do that. Because we have 1, 2, 3, 4, 5, 6, 7. Let's pretend like that's 8. Okay? All right, so anyone think they know where the graph is going to be? If you had a guess. We have these asymptotes. We have this asymptote. We have this asymptote. But we have these two solid points. Where do you think you're going to be? So you don't cross this line, and you don't cross over here, but you've got to pass through these 2 points. You're going to be somewhere here and somewhere in this region. Is there a hole? Nada. No hole. Your exclusion chart, you're going to put x plus 2, x squared minus 2x plus 4, which this is going to give us nothing. This is going to be all positives. So let's just put these two down, x plus 2, because the positives don't give us any indication of if they don't, the only thing that changes is the number of negatives that you have. So let's just do -2 and -1. Let's make this easy for us. So our 0 is here. Whoops. Our 0 is here. So we have negative, positive, positive. Then here we have our 0 right here. Negative, negative, positive. So according to this, we are where? First we're positive, then we're negative, and then we're positive. So positive, negative, positive. Okay, so from up to -2, it says we are positive. So from here to here, we're positive. So it's going to look like this. Then from -2 to -1, which is in this region, we're negative right there. This should be like kind of like a curvy, not straight. Then from -1 to infinity, we are in the positive region. So I bet you it's some kind of like parabola of some sort. So this is what your graph kind of looks like. Kind of. This is just a rough sketch. This is just a rough idea based on, so something like that, and then something like this. So let me type this in my calculator, and let's see what kind of lovely picture I get. New document. So we're going to add a graph. We're going to put a fraction down. Now, just go to the original problem. You don't have to worry about it being factored. X cubed plus 8 over x plus 1. And there it is. Ashley, did the video turn on? No, okay. So there's our graph. This piece is right here, and then this little parabola is this right here. Last one. This is the grand finale. It takes up a whole sheet of paper. So let's see what we can do. Can you tell me how to factor this completely? Is there anything you can take out of this numerator? Take an x out. If I take an x out, what's left? X squared plus 4x minus 5. Well, is this leftover factorable?
Yeah.
How do you factor it?
X plus 5 times x minus 1.
Yep. So guess what I have right now? I have 3, unless I cancel anything out. Let me factor x squared minus 4. How does that factor? How does x squared minus 4 factor?
Minus 2 times x plus 2.
Mm-hmm. How about x squared minus 9?
X minus 2 times x plus 2.
Am I removing anything from this? No. So guess what? You got a point. There's no hole. What else can you do? What are my zeros? There's 3 of them. Your roots, these are your zeros. What are they? 0, -5, and 1. 0, -5, and 1. You're going to put a dot at 0. You're going to put a dot at -5. 1, 2, 3, 4. Let's make that -5 right there. And at 1. So my graph is going to cross the x-axis. It's going to pick up those 3 points. My vertical asymptotes, wow, I have 4 of them. What are my 4 vertical asymptotes? How do you graph x equals 2, -2? There's x equals -2. You put them all in. X equals -3. X equals +2. And x equals +3. So far, we have 3 zeros. We have 4 vertical asymptotes. And we have no holes. What else do we know? What else can we figure out? Is there a horizontal asymptote? Is there a slant? Or is there a parabolic? We have to check out the degree. The degree of the top is x cubed. But what's the degree of the bottom? x4. Thank you, Regine. So it's bottom heavy. Bottom heavy means these are top heavy. Y equals 0. Well, where is y equals 0? This is y equals 0. Now check this out. Look what we have here. How can this be an asymptote, but yet these 3 points go through them? A horizontal asymptote is a weak asymptote. It's more for the end behavior, way, way out. That's where it's more for. A graph can cross a horizontal asymptote. They're not very strong. Okay, so yes, we can have these points. Now, you will not have points like way out and then it cross. It's more, the graph is coming from, it's going to be real close to these 2 ends, these asymptotes. Your y-intercept, if I were to put a 0 here, a 0 here, a 0 here, a 0 here, and a 0 here, you get 0, 0. So that's not a problem. 0, 0. Now this T-chart, guess what you're going to have? Does anyone think they know how to fill out this T-chart? Or exclusion chart, I should say. What are all of my critical values? What's this one? We have 0, we have -5, we have 1.
+2.
Okay, so see, these numbers are your critical values. I need you to organize them on this chart, left to right. So what's the smallest one? Then we have, 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 and then we have 3. Now over here, I didn't give you I need another column. Not another row, but another column. I have too many rows, not enough columns. So I want you to list all of these little pieces. X plus 5, X minus 1, X minus 2, X minus 3, X plus 2, and these don't matter what order.
Thank you.
So these are all of the pieces. X plus 5, X minus 1. There should be 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yep. And what's the grand finale? You're going to count. You're going to have your f of x at the bottom. Okay, so let's do the first one. Which one of these is my 0 up here? 0, right here. So any number to the left of that on a number line is negative, and then positive. Next one, x plus 5. Where's my 0? Which one is it? Is it this one? Yep. Negative, these are all positive. X minus 1, where's my 0? 1. These are negative, positive. X minus 2. Oops. Negative, negative. X minus 3. Negative 2. And then x plus 3, so negative 3. Okay, now what are we going to do? What do I do now? Now we count. 1, 2, 3, 4, 5, 6, 7. How many negatives? 1, 2, 3, 4, 5, 6, 7. How many do we have here? 1, 2, 3, 4, 5, 6. 6 is even. 1, 2, 3, 4, 5. 1, 2, 3, 4. 4 is even. 1, 2, 3. 1, 2. So according to my little table here, my exclusion chart, from negative infinity to negative 5, where are we at? In the negative region. Well, where's negative 5? Right here. So we need to be in this region. So we're just going to go like that. From negative 5 to negative 3, where does it say we are? What does it say? Positive. So we're going to be above the x-axis. We've got an asymptote to guide us. Now, from negative 3 to negative 2, this says we are in the negative region. But we've got this tiny space here, and we do have an asymptote. So when that happens, you're going to see a parabola, like a little parabola. From -2 to 0, it says we're in the positive region. From 0 to 1, it says we're in the negative, but we can't go too far down because we have to come back up and pick up that point. From 1 to 2, it says we're in the positive region. From 2 to 3, it says we're back in the negative, something like that. And 3 to infinity, we're in the positive. So I'm going to draw, this is a sketch. This is an idea. This is where I think we're at. How can I make sure where we're at? Well, I can type it in my calculator. Let's do that. Let's type this monster in the calculator. So, fraction, we've got x raised to the third power plus 4x squared minus 5x. And then down we have x squared minus 4. And notice how I'm just typing it in my calculator exactly the way it shows up in the original problem. Check this out. I'm just typing it in. And then x squared minus 9. Now, let's see how, whoops, that was bad. X squared minus 9. Now it's good. Hit enter. Check this out. How close are we? That's our graph. And look at that. The only way to get any more accurate is to make a table of values, and you'd be putting a lot of numbers and it'd be a lot of work. This is the hardest problem. But what's nice about this problem is that once you do this one, you kind of understand it a little bit better. So what do I want you to do for homework? The rest of these. Tomorrow we will let you work on them and answer questions, but you have to have them all done by tomorrow. So please, don't wait till tomorrow to start this. It's a lot of work.